Hello everybody and welcome to this tutorial which I'm creating based on the request of my friend Raleigh. It's basically just how to make a rotational motion or a rolling motion for this ball over this inclined surface. So as usual, let me start with a new assembly file. Okay, so the first part will be this one. I need it to be fixed. Then okay. Now the second part is the ball, as you see here, my friend. Now what we need to do is to make this ball make a rolling over this surface. So we leave it without any constraint now. As you see, it has 6 degrees of freedom, so you can drag it in any direction. Okay, so now let me go to applications mechanism, and in this case the most important thing is to define a 3D contact between this point and the surface. So we go to 3D contact and select this surface, also these, hold Control and select all these. Okay, so here the main parameter which controls the sliding or the rolling is the value of the friction coefficient. So in this case you have two options here. The first one is to define the friction coefficient values manually, or the second one is to define a material for each and every one, and then you will make an actual simulation with an actual material. So let me try the second option and go to contact, then select material, then click on more. As you see, you have the list of materials that are in PTC Creo. So let me take the nylon, for example, open, and the PVC, also open. As you see, they are listed here now. Then okay. So the first contact, which is the ball, I want it to be a nylon ball, and here select material again, and I want this body to be from PVC. Then okay. Now the most important point also is to set the ball in the right position. So I'm going to select left, then go to drag component and drag this ball to its initial position that you want. As you see, my friend, if you try to move this slowly here, you can feel the contact between the ball and this surface. Then okay. Now we have to define the masses for these parts. So we go to mass properties, select this one, apply, okay. Also for the ball, mass properties, select the ball, apply, okay. And another point is to define the direction of gravity acceleration. So it's not in the direction that we want here. So let me flip this to be 1 and this to be, and check it again. It's in the z direction. So 1, then okay. Again, let me check it. Okay. We have the acceleration of gravity in the right or correct direction. Then okay. All we need to do now is just to run the simulation. So we go to mechanism analysis. We choose dynamic analysis here. Let me reduce this to 5 and go to external loads and activate the gravity and the frictions. Then what you need to do now is just to click run. Okay, so let me see the motion again. we go to playback, select the final analysis, then run, then OK. So we watch this slowly now. OK. So if we try the second option, go to connections and edit the definition for this contact. I'll set this contact here, sorry. Yes. For this contact, I'll select use values, and for this use values, you can define the values for the properties of this material, or you can simply go to no friction and activate frictions. I will set this to 0.7 and this to 0.6, then OK. I'll go to the left plane and drag this ball to be here. Now again to mechanism analysis, to dynamic, this to be 4 or 5, and activate these. Now run. OK. So let me see this again. As you see, my friend, here, it's obvious that the ball makes a rolling motion, and this is a fully dynamic analysis. So you have to control the shape or the surface you want the rolling to be over, and also you have to control the conditions of the friction, so you can get the result that you want to. I hope you understand everything. Thanks for watching.